In this video, we're given a couple of exponential equations that we're going to solve. Now, there's a few different ways that we could solve them, but we're going to use the inverse to go ahead and do that. If we take a look at our equation, the problem that we have here is that there's a variable in the exponent, and that messes us up. And that's why we're going to have to use the inverse to solve for x. Now, before I get into the inverse, I want to refer you to the form of an exponential function written right here. Well, the inverse, remember, is just switching the x and the y. So we had y equals b to the x power. Well, the inverse of that is going to be x equals b to the y power. And if you're asking, well, why does that help us? Well, the log form, or the log scale, can be applied to this. This equation right here, where we have y equals log base b of x, that's the same thing as x equals b to the y power. You could write the inverse of the exponential function in either of these forms. You could just switch the x and y, or you could write it with the log scale. And the nice thing about this is when you switch from exponential form here, the exponent, which was y, is now to the left of the equal sign here, and it's kind of level. It's not in the exponent anymore. And that's what we're looking for, because we don't want this variable right here, the x, in the exponent anymore. So what we're going to do is assume that this equation right here is in this form, right? X equals b to the y power. And I want to write it with the log. So I'm going to write log out, log, and here I see there's a big base, and then we got to write the little base, which is that little b. So the big base here is 2. I'm going to write that as the little base right there. Now, next to the base, right here, this x variable, that came from the lone side over here on the equal sign. So what was left by itself on one part of the equal sign opposite of the base? That was the 16. That's on the opposite side of the equal sign. So now it matches up with the little base. So we're going to write in parentheses right here 16. And that's going to be set equal to this exponent, which is negative 3x plus 1. And that whole process of switching form could be tricky for some people, but what I like to say is you just take this big base here, that b, make it the little base, and then switch the spots of your x and your y, and you would get what you need. So now you could evaluate log base b of 16 in your calculator, and you're going to get 4, and that's because 2 to the 4th power gives us 16. So you could have also asked yourself, 2 to what power gives you 16? So that's going to be 4, which equals negative 3x plus 1. Okay, now we just want to finish solving this like a regular equation. So we're going to take away 1 from both sides. That's going to be 3 equals negative 3x. Then we're going to divide by a negative 3. That goes away. Divide this side by a negative 3. And we're left with x equaling a negative 1. And that's going to be our final answer. In part B, we're going to use the inverse to solve as well, and switch forms and all that stuff. But before we do that, we have to isolate the base with that exponent. So we need to get that 10 to the x plus 1 power by itself. So the first thing that we're going to do is add 7 to this left side, and then add 7 over there. We're left with 2 times 10 to the x plus 1 power equals 16. And then we're going to divide out the 2. That goes away. Divide this side by 2 as well. Now we're left with 10 to the x plus 1 power equals 8. Now we could switch forms. So we're going to use the inverse of exponential functions, and we're going to start with exponential form right here. So remember what I said before. I like to write I like to write log first, and then I take that big base, in this case it's 10, and I make it my little base. And then all I do is switch spots here. So with this 10, I'm going to have that 8, and on the other side of the equal sign, I put my exponent. And then I could solve from here. Now, offhand, I don't know what 10 to a power will be 8. Imagine if you add 10 to the x power equals 8. I don't know what that is, so I'm going to use my calculator to evaluate it. That's going to be 0.9031. So that's an estimation there. And then we have x plus 1. And then all I have to do is take away 1 from both sides. That goes away. and then we're left with a negative 0.0969, and that's going to be what x approximately equals.